Welcome to the Chapter 22, 12, and 14 Addendum Notes, Radiation and Waves. Make sure that you have another piece of paper on the side to jot down notes that are not on the reading guide that we went through. Again, write down any questions you have as you go through, then just ask me in class. Let's take a moment to overview some of the things you need to remember, like the scientists and who pioneered radioactivity and research. Explain some elements that are radioactive and why they're radioactive. Describe characteristics of nuclear radiation. How gamma rays, how are they created, their properties, and how they can harm us and give us cancer, yet we use gamma rays to treat cancer. So what is sound? How can we create it? How would our bodies create sound with our voice? And how does sound travel at different speeds through different substances? What is the Doppler effect? How is it created? And be able to diagram and explain the Doppler effect, which will be on the next big ginormous quiz. The beginning of the research with radioactivity started with Henry Becquerel. He was French. First discovered nuclear radiation working with uranium. Marie Curie, Madame Curie, and her husband Pierre Curie then worked underneath Henry Becquerel and went on to discover polonium and radium. As a side note, Marie Curie is the only scientist ever, including Einstein or anyone else, who got a Nobel Prize for physics and chemistry. And she named polonium after her home country, Poland. So we've all heard about radioactivity, radiation, but what is it? And so the short answer, this is happening inside the nucleus, and this is really hard to describe, but we understand gravity, we understand static electricity, but now we have nuclear force, or strong nuclear force. This is holding actually protons and protons together. So what happens is if we have too many neutrons, we say that the nucleus is unstable. And anything above has an atomic number over 84 is radioactive. So too many protons in the nucleus repelling each other because we have too many or too few neutrons. And really we can have any element on the periodic table can be radioactive if it has, again, too many or too few neutrons, including hydrogen, helium, all the way up, again, to anything 84 or above. So things you need to know about radiation well past the big ginormous quiz coming up, at least until you're 87. So the big thing, you can't see it. So how do you know it's there? We're going to bypass this for a second. And then fluorescence. It can glow in the dark, or just glow. Doctors can actually use things with a very short half-life. You can drink it or they'll inject it, and then they can actually see these radioactive materials flowing through your brain or your kidney or other parts of your body. And this breaks down very quickly, but we're able to see with machines how the blood flows and how it works through your body. So everything that's radioactive can give off waves, but it also can give off particles. So these charges. So we use these little, kind of looks like a metal lunchbox and looks like a little microphone with a cord. These are Geiger counters. So they'll kind of click, 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 click if you have more radiation. And if there's a lot of radiation, even if you're wearing these suits, you can get a heavy dose of radiation. So don't do it. So those heavy dose will kill your cells. The one thing that for sure can kill you and give you cancer is radiation. And again, one of the ways we treat cancer is radiation. So way back when they first discovered things were radioactive, because they had rocks and they were examining rocks and they had some undeveloped photo film. This is over 100 years ago, and then it would actually make patterns and different things on the photographic film. Now, if you have the old school photographic film and you're traveling by air, you don't really want that going through the X-ray machines because it can actually damage your film. Gamma rays. This stuff is the most damaging waves. So, high frequency, short wavelength, high energy. most penetrating radiation given off by radioactive elements. So it can go through several feet of concrete, even lead, over an inch. And lead is very dense, and that's why when you go to the dentist and they put a big heavy apron on you, there's lead in it to help protect your body parts. When you take the year-long chemistry class, you'll talk about alpha and beta particles along with gamma rays. But we use cobalt-60, which produces gamma rays, and we use this to target tumors very specifically to treat cancer. So sound waves. So this is kind of harking back to earlier in the year. We talked about different types of energy. So sound is actually mechanical energy. So mechanical energy, just like kinetic energy, is the energy of motion. So things are moving. When you talk, there's vibrations, and it actually moves air particles. So that movement of air particles is the motion. And there's different frequencies. The higher the frequency, again, units is hertz, lower frequency. And so what actually these sound waves are hitting your ear drum or tympanic membrane, which is actually vibrating, and then that mechanical energy, that vibrations get converted into chemical signals in your brain, and you interpret that as sound. Thankfully, through modern medicine and technology, we can actually put a scope down your throat, which is basically fiber optics or bending glass, and it will bend the light, and we can actually video record putting a tube down your throat, going through your vocal cords into your stomach, and we can quote-unquote scope your stomach. So just like the strings of a guitar or the strings in the piano, it's the vibration. So they vibrate, again, longitudinal, very important. So the particles move in the same direction as the wave. So as air goes through your lungs, your vocal cords vibrate. This won't be on the quiz, but there is compressions and rarefactions, where they're compressed and there's space between these vocal cords. So think about a person, he's going to yell, just like in the cartoons. And then the sound waves start to spread out. So if you can actually see the sound waves, these are these bunches of air particles that are compressed together. And these are the particles that then hit your eardrum. So depending on the temperature, elasticity, the density of the air or the substance that's going through, the speed of sound is 750 to 760 miles per hour. So we're all aware that sound travels differently in different substances or mediums. So if you want to absorb sound, you want it to be quiet, you have nice fluffy styrofoam and that'll absorb the sound. But if you want it to travel quicker, you can actually have solids like metals, like steel and iron. So way back when, if you put your ear to the train tracks, you can actually hear the train coming miles and miles away. Or if you go underneath the water at Buc-ee's, you can hear a ship miles and miles away because sound travels faster and farther in water than it does air. Now last year in Earth Science, or in other classes, you learned about the Doppler effect. So usually we hear it for sound, but it also occurs in light. So in astronomy, we can actually see stars moving towards us with special telescope, and you actually have, it's called a blue shift. So if we know if stars are moving away from us, because it's a red shift, and if it's getting closer to us, it's a blue shift, and this is the Doppler effect with light. So when something is, again, moving, when we're talking about sound with a Doppler effect, now if something is not moving, all the sound waves are actually evenly spaced apart. But if we're moving towards an object, all these sound waves are very compressed and we have a higher pitch. And if it's behind us, then it's a lower pitch. So movement changes sound waves and light. Nice drawing, Mr. Heflin. This may be on the next Big Giant Numbers quiz, just to let you know. Again, review all the pieces of information from this video. If you don't remember something, then go back, review just that part of the video, Write down any questions you have. Have a great day.